multiplying complex numbers. So let's start with, what is standard form for a complex number? What is standard form for a complex number? A plus BI. Okay, standard form for a complex number is A plus BI. Oops. And there are two parts to this complex number. There are two parts to this complex number. What are the two parts? What are the two parts to the complex number? The real part and the imaginary part. Which part is real? A. So your constant is your real part. The BI, right? I is the imaginary. So the part with the I is the imaginary part. So you have a complex number, A plus BI. It's in standard form. You have a real part and you have an imaginary part. When we are multiplying complex numbers, we're going to do the same thing we've been doing all semester. You can use the distributive property. We can use box. Or like the big distribution if we have a binomial times a binomial. Okay? But before we do that, what is the square root of -1? What is the square root of -1? Y'all just did it in your warm-up. I. 1i. Okay, so because the square root of 1 is 1, but that negative makes it an I. So the square root of -1 is I. Yes? Okay. What if I give you this statement? I squared equals -1. Are these two statements equivalent? Meaning, are they the same? How do I get rid of a square root? Who remembers how do we get rid of a square root? We square it, right? To get rid of a square root, I square it. And whatever you do to one side, you have to do to the other side. Well, if I want to get rid of this, -1 equals I squared. Okay, so these are equivalent no matter how we write them. The square root of -1 is I. I squared is going to be -1. This is going to be important for this unit. This is going to be the hardest part, understanding that. Is everyone okay with that? Okay, so you might want to underline, bold, highlight, box. Like this is important here. You need to know this. Okay, those mean the same thing. You need to know that. We're going to write our expressions. As a complex number in standard form. So write the expression as a complex number in standard form. So I have 4i times negative 6 plus I. Okay. What does this look like to you? I heard it from MJ. Anyone else? What does this look like? Distributive property. It's what you've been doing for years, right? So let's distribute, just like normal. Okay? 4I times negative 6 is negative 24I. Right? What's 4I times I? 4I squared. Everyone okay so far? Okay, but we said standard form is A plus BI. There's no squareds in that. Do you agree? What is I squared? I squared is negative 1. Okay, so again, this is the hardest part. Remembering that we are going to replace I squared with negative 1. So negative 24I stays plus 4, and we're replacing the I squared with negative 1. We need to simplify it, and we need to write it in standard form. So it's negative 24I minus 4, but that minus 4 is going to go out front. Is that in the form A plus BI? Okay, so the multiplying part's not hard. It's the remembering to change I squared to a negative 1. Are you okay with that? Yeah? Okay, so let's see if you can do this one. So if I distribute in this case, I have 9I minus I squared, right? I'm replacing I squared with negative 1. Now, some of you are going to be able to do this in your head, and that's fine. I'm replacing I squared with negative 1. Now, you also have to write it in standard form. So, A plus BI. What happens here? Becomes a positive 1 plus that 9I. So, you should have 1 plus 9I as your answer. Are you okay with that? Okay. So what if we look at this one? We've seen stuff like this before, right? What are my options? Distribute or box? Do we have a preference? Okay. We said distribute, so let's go distribute. If you prefer the box, I'll do it on the next one. So if I distribute 9 times negative 4 is negative 36, okay. 9 times 7I, 63I. Negative 2I times negative 4, 8I. And negative 2I times 7I, negative 14I squared. Okay, some of you may do this in a different order, but let's combine our like terms first. So 36 doesn't add with anything yet. 63 plus 8 is, okay, 71I. And then I have the minus 14I squared. Now, that looks great if we didn't have all the imaginary numbers. What do I have to do here? Replace I squared with negative 1. So I'm going to just see if I can write over it. Everyone have this part? I'm going to replace this with negative 1. Because now I have a positive 14. And what's negative 36 plus 14? Negative 22. So negative 22 plus 71i is going to be my answer. I want to show you something with the box as soon as we get to it, which might be helpful. Are we okay with that? Yeah? Okay, let's do this this one together, and then I'll have you do one on your own. And I'm going to do this one with the box because I want to show you kind of how I can organize it. So 3 plus I times 5 minus I. Okay, so if I use the box, and if you don't want to use the box, don't use the box. I have a 3 and an I and a 5 minus I. How do we get in the box? Good. How do we get in the box? I can't hear whispering. I'm old. How do we get in the box? Thank you. We multiply. I heard that one a little bit louder. Okay, so 3 times 5 is 15. 3 times negative I is negative 3i. 5 times I is 5i. I times negative I is negative I squared. Okay? Remember, your like terms are at the diagonal. So here's my like term. And before I take everything out, I know I have to replace I squared with what? Negative 1. So I'm going to replace it there with a negative 1, which really gives me a positive 1 right here. Are these now like terms? Yes. 15 plus 1 is 16. 5 minus 3, 2i. You don't have to use the box. You can distribute. The big thing is remembering to replace I squared with negative 1. Okay, you try this one. Did anyone notice anything about this problem? Brooklyn, I think I heard you say something maybe? You can use a trick. Did anyone else notice that this one was special? No? And if you didn't, that's okay, right? You use box or distribution. Remember, what is it called for this particular one? What makes it special? Difference of squares, I heard. So if it's difference of squares, you can multiply the first terms and the last terms. If you don't notice that it's difference of squares, you're going to use the box, and those middle terms are going to cancel because you're going to have a 6i and a negative 6i that cancel out. 3 times 3 is 9. 2 times negative 2i is negative 4i squared. But remember, I'm replacing I squared with negative 1. So it's really 9 plus 4 for a total of 13. Are you okay with that? Okay. What if I give you one that looks like this? We're going to do it together, but I want to talk about what we're going to do first. You have a couple options with this. We can start a few different ways. Anyone have a preference? What do you want to do first? because that's what we'll do first. Any ideas? Nothing? No one has an idea of what we can do? Okay, let's distribute the 3i. I'm okay with that. So we're going to ignore this last set of parentheses, and we're just going to deal with this first part. So 6i minus 3i squared. Right? Okay, again, I'm ignoring this for now. Can I simplify that at all? Yeah, how can I simplify this? Replace I squared with -1. So -3 times -1 is a +3. So I really have 3 plus 6i. Now, does that look any different than the problem above? Nope. Okay, I want you to solve that. So since most of us are distributing, I'll distribute. 3 times 1 is 3. 3 times -4i is -12i. 6i times 1 is 6i. 6i times -4i is -24i squared. I know I'm replacing I squared with -1. So this is really a +24 right here. Everyone okay with that? 3 plus 24 is 27. -12 plus 6 is -6i. Did we get that? Awesome. We're not going to necessarily solve this problem, but I want to look at it. Okay, we're not going to necessarily solve it, but let's talk about what we would do. Or do you just want to do it together? Okay, so what would we do? Distribute and deal with what? And distribute everything all at once. What are we going to do? Headphones off. What are we going to do? Talk to me. You're just going to look at the problem and not do it? Huh? We can't combine like terms because we're multiplying. Can I ignore this? And does that look anything different than what we've been doing? No. So ignore the last set of parentheses, and we're going to multiply it out. Okay? Ignore the last set of parentheses. Let's just do it since nobody wanted to talk to me. Multiply it out. So 2 times 4 is 8. 2 times 3i is 6i. -7 times 4 is -28i. -7 times 3i is -21i squared. So all I dealt with right now is this first group. I ignored that last set. What do we replace I squared with? -1. So this is really a +21. 8 plus 21, 29. 6 minus 28, -22i. So that's what's left over. But I still have this set. That is a lot of steps. Okay, let's multiply it out and then we'll be done. 29 times 1 is 29. 29 times -2i, -58i. -22i times 1 is a -22i. -22i times -2i is a +44i squared. Okay. I replace I squared with negative 1, so this is really a negative 44. What's 29 minus 44? Negative 15. And negative 58 minus 22 is a negative 80i. So yes, it's more work. Are you capable of doing it? Yes, you just have to do it one step at a time.